here?
Yeah.
Just because I had a little bit different book. Just wanted to make sure this is exact.
Oh, let's see. So is that the McKee book or the?
Yeah, it's in the queue.
I think yours is right. 2425. I think the beginning of it should be the same.
In one variable?
Yeah.
Okay.
Real quick, look at the homework real quick. Well, everybody else is like, yeah, good. So same thing. Sweet.
Thank you.
Yay! So, we did some work with absolute valued equations. So let me go back over that real quick. Page number. Well, it's section 2526 in McKee, I think it is, and 3445. Let's see if I'm right. Yeah, so it's one more section past where we were looking. It's the page 133 and 141, 2526. So we talked a little bit about absolute value equations. Let me see how much you guys remember about that. So try to solve that. And while you guys are doing that, is there anybody who didn't get their test back yet? By the way, that's not 14x minus 11, right? I was trying to make those bigger somehow.
I was like,
I did just say absolute value equations, right? Totally. Yeah. We'll cheer. They don't listen to me.
for this one, there's two possible answers.
Yep. So, what's the first step to set this up before you can really start solving it? Can I just start adding 1 to it?
No.
Hell no, I can't break into something like, I can't break in there. I've got to somehow remove those things. Parentheses are easy to remove, just distribute or whatever. Absolute values, I've got to apply the idea. And absolute value idea says, what would this be to make it 7? Well, it could be 7,
Minus 7.
or the thing could be negative 7. And then you can just solve those two equations. So add 1, divide by 4. Add 1, divide by 4. Is that cool?
Yeah.
So anytime you have absolute value equations or inequalities, there will always be two cases. And does that make sense? Does it fundamentally make sense? I mean, if I just look at this, what can I put in here to make it true?
Negative or positive?
Negative 7 or positive 7. So that's all I'm saying. What would this have to be to make this true? It has to be 7 or it has to be negative 7. And you just solve to see what x makes those true. Cool. So, what about this here? So what do you think you have to do first here? Yes?
Subtract 3
On both
the other
sides.
side.
Okay, cool. Yeah, you can't apply this idea until you get the absolute value by itself. Now, I am going to show you another way to do these kind of problems, and I'm always hesitant to show more than one way with something like this, but I do want to show you that other way, because it's going to make something later make a little more sense.
After you subtract the 3, do you do anything with that negative?
Yeah, you have to.
Negative 5.
So do I have this thing by itself yet? No.
Okay.
So then what do I have to do to both sides?
Divide by -1.
Divide by -1. And now it's exactly the same as that. I can go ahead and apply the idea. Right?
Wait, is that -1?
It was.
I mean, I'm like, okay.
And then I divide both sides by -1.
So you keep that absolute value the same.
Definitely. Because I haven't done anything with the absolute value yet. I've just messed with stuff outside of it. But I have to get it by itself first before I can apply an idea like this. So what's the next step here?
5 minus 3x equal 1. 5 minus 3x equal -1.
I like it. Cool. And now you just solve those. Right? Subtract the 5, divide by the -3, or subtract the 5, divide by the -3. Cool. Not too bad, right? Just got to remember, absolute values have to mean something. They can't. A lot of times, I have people just start working on them like they're not there. I'm like, why would they be there if they don't need to be there? Doesn't make any sense. Let me show you a different way to do the same problem, and then you could do it either way you want to, whatever makes more sense. So I'm going to do the same problem again, a different way. And this way requires, it's a little bit quicker, but anytime it's quicker, it almost always means that it requires a little more understanding. So on the side here, can anybody tell me what's the absolute value of x?
-1. Plus any number.
It's not, the answer is not x. I want it to be something to do with x. The answer, you would think it'd be x, and why would you think the answer would be x? Because you look at it and you say, well, that's not negative. But how do you know? Right? What is x? Anything I want it to be, right? X is all real numbers, any number that I want it to be. So it could be positive or it could be negative. So the answer here is actually not one answer, it's two. If x is positive, this would leave it alone. If x is negative, it would be the opposite of what it is. Think about it. People freak out when they see this because they say, Jeff, you said the absolute value can't be negative. Well, this isn't negative, is it? If x is negative, what's negative times x? Positive. You with me? I mean, if x is -7, this would be -7, which would be +7. That's fine. The bad part about this is the absolute value does different things depending on what's inside it. If I put a variable inside, it's like, shit, I don't know what the hell to do. I don't know what the hell it is. So I'll just say it's this if it's that kind of number, or it's this if it's that kind of number. This was another way to say what the absolute value does. If it's positive, it don't do a damn thing. If it's negative, it changes the sign of it. That's exactly what that says. Right? So what's that got to do with this problem? One way I can solve this problem is to say, okay, either the absolute value of this is going to be the same thing, or the absolute value of this is going to be the opposite of this thing. And you can see why I don't always show this. So the absolute value of this will either be the same number if it's a positive number, or it'll be the negative of this number if that happens to be negative. Because I don't know what the hell it is. Now, which way is preferable? Preferable? Which way is preferable? Which way is the better way? This way is a little less messy, but this way is actually a little more to the point. So I don't care which way you do it. I don't know if you've ever seen this way before, possibly. But if you solve this, you're going to get the same thing we got down here. All right, just bring that. Here, this is kind of funky. So you get 3 plus 5 minus 3x. So here I get negative 2, add the 2, divide by 3, I get 4/3, the same way we got 4/3. Here I'll get 8, subtract the 8, it's negative 6 divided by negative 3, I still get 2. Of course I still get the same answers. But it definitely requires a little more, understanding what's really going on. It's a little less of a comfortable way to do this. Okay. But I'm going to come back to that idea later when we do the inequalities. Because this actually makes it a little bit clearer what's going on there. So any questions? You can always do this. If you want to do it the other way, you have to get the absolute value by itself first, and then you can set up the two cases. Cool. Now, of course, what if I gave you this problem here? I think this is sort of like, the bonus section number 2 on the test. If I give you this, you could set up your cases, and you could do the work, and you can get 2 answers. Those 2 answers will both be bogus, because what's going on here? From the very beginning.
There's a negative.
Yeah, can the absolute value equal a negative number? No, so what's the answer? No solution. Right? So if you do the work, if you set up the 2 cases, you'll get 2 answers, but neither one of them will work, of course. Because there's no way you can get a negative 2 out of this. So this one, no solution. So what if I do this to it? That's a little more like the bonus question. Same reasoning. It's no solution because that just makes it even more negative, possibly. So the absolute value still can't do that.
No, it's positive.
What if it's positive?
Positive.
Then you got to do the work. That's going to be the next level. Yeah, we're not there yet. The next thing we're going to talk about is absolute value inequalities. Yeah.
If the sign is greater than -2, that would be.
Then you can do it. Then you can do it. And then I could just change the number to a 0, because that's the first place it actually makes any sense. That gets a little freaky. Yeah. Okay. So let's step into absolute value inequalities. So let's take a very simple case. This is fine. Let's do this. Make it a 1, Jeff. Make it a 2. There you go. So I'm going to look at this problem. Since it's a very basic problem, the x has no coefficient, there's not much going on. There's actually a different way. I can kind of look at it visually, like we did with the equations. I don't know if you remember that. We just said, recall. We did, if I had this kind of problem, remember what this really means? The distance between a number and 1. So if I put 1 here, the distance between a number and 1 is 4. So I can either go up 4 or I can go down 4. So if I did the work here, I would end up with those answers. You guys remember doing that? No. Yes, ma'am.
Oh, wait. So how come there's an equal sign there, and you do that anyways? So there doesn't have to be a greater or less.
No, okay. So this is what we did earlier when we first started talking about absolute value equations. The very first thing I did was an example like this, where we had a very visual idea. I mean, absolute value means what? Why does absolute value always come out positive? What idea is absolute value based on? All right, I remember talking about this. So why is absolute value always positive? Not just because you're told so. Why? Yeah. Yeah, it's the distance from 0. So when I see a problem like this, this says the distance between a number and 1 is 4. So what two numbers could that be? I could either go up 4 from 1, which would be 5, or I can go down 4 from 1, which would be negative 3. So if I do the work, you see those two things happening. You see that right there. Okay, so that's why this kind of thing makes sense. When I see an absolute value in something, that means distance. So when I see an absolute value equation, that's saying I want to set this distance to be 4 in this case. So what numbers are 4 away from 1? 5 and negative 3. Because distance doesn't care what direction you go. I went 4 feet, and I went negative 4. No, I didn't. I went 4 feet both times. Right? Negative distance is weird. So this I can do it pretty much the same way. The inequality, we'll figure out how it fits into this mess. Right? So what's this really say? The distance between some number and 2, it's got to be less than 4. It's got to be closer than 4, right? I can't get 4 away. So if I put 2 here, what's the most it can go up? Up to 6. And what's the most it can go down? Negative 2, right? If I can get at most 4 away from 2, that's what that says. The distance between a number and 2 has got to be less than 4. You got to be closer to me than 4 feet away, or whatever, however you want to think of it. So I can, if I start at 2, I can go up to 6, and I can go down to negative 2. That's within 4 away from 2, right? That's exactly. Can I include these? Is it allowed to be exactly 4 away? No, I can't be exactly 4 away. There is no equal sign there. Right? So then I have to do this. So that's what I call the sandwich idea.
So that's
Keep it close. Stay close to me.
So that's your solution, John? Like this?
Yeah. So my solution for this would actually somehow come out to be that. Yep.
So why is there 6 included?
6 is not included. Definitely not. I have to be less than 4 away, but 6 is exactly 4 away, so I can't include that. If I would have put less than or equal to, those two would have had brackets on them, right?
And then would be in the middle.
Yep, exactly. So in this case, that's shade right in the middle. So I am not showing you how to do the problem yet. I'm showing you why these problems will work the way they do. So when it's less than, I desperately want you to get this. Even if you don't understand the exact specifics of what I just did here, I want you to understand this idea. Absolute values are distance. When it says less than, I want to keep it close to me. So I'm going to have something like this. That picture here. If I said greater than, that's what I call a restraining order. Stay the hell away from me. I'm going to have a picture that looks like this. So what the hell is that going to look like? So I am still not showing you algebraic process yet. Are you with me? I'm just going over the idea. Right? And I know that's kind of like, some of you guys are thinking, I got to do this for these problems. No, you don't have to ever do this. Ever. This is me just showing you the idea. And I know that's painful sometimes. So let's look at the other idea. Alright, so where would I start on this problem? And what would be right in the middle? 3. So the distance between some number and 3 has to be at least 6. Right? So the judge says you must stay at least 6 feet away. That's the weirdest restraining order ever. But we're going to work with it. So if I start at 3.
So it doesn't matter that it's negative 3? Just 3.
Distance between two things is what operation? The distance between two numbers would be what operation? Subtraction. So that subtraction is part of the idea of distance. So what two numbers am I looking at? Some number and 3. Where it gets weird if it's a plus. We did that the other day. I have to write it as minus and negative. Then I'm talking about a negative number. Okay. So how close can I get? Here I am.
9.
Right? Here's my ex, who I did something horrible to. How close can I get to her? Yeah.
9.
9. Right? It's going to stick in your brain, isn't it? And so I can't get closer, can I? I can be here. I can be there. She probably wants me to be there. But I can get right up here. I can be right there. And just throw things at her. Yeah. All right, this is a very strange example. Just go with it. So how do I represent that visually then with inequality kind of symbol stuff going on? What's going to be on the 9? A bracket.
Bracket.
And I want to shade which direction?
Other side.
Up this way, right? I can be anywhere up here. And of course the same thing down below. How close can I come this way while she's looking the other way? This is horrible. And then of course what symbol is going to be there? Bracket, because I can get right there and anywhere down below that.
Why you shade this side and this side?
Why? Because if I try to do anything here, that's closer to 3 than I should have been able to get. I have to stay at least 6 away. 6 away up here, or 6 away down there. Right, so isn't this more than 6 away from that? And any number in here is more than 6 away from that, so that's why I shade that way. Because those actually answer that idea. Yeah?
Okay, so the equation there with x minus 3 would do greater than 6, and then the opposite would be less
Yeah, so let's start talking about algebraic process now. Finally, right? So enough with this. That's cute, Jeff, about the stuff and the sandwich and the restraining order. But we can only take so much cute. So let's talk about algebraic process. So if I have a problem, let's start with this one since it's right here. If I have this problem, if I have a greater than, if I have the absolute value greater than something, that's going to be the stay away from. It's going to be 2 separate things. You with me? So I'm still going to have my 2 cases. And let me just show you. All right. So there's a lot to kind of go through. Just don't worry. It's all going to come together at the end. If I look at it that second way, that weirder way, I can replace this. One case would be it stays the same. Is that cool? Like if x is 7, that's a 4. It's going to stay the same. That's the value. It's going to leave it alone. Or this is going to become the opposite of what it is, right? If x is -4, what number is this? -7. What would the absolute value of that be?
7.
The opposite of -7. You with me? So the absolute value is going to leave it alone, or it's going to change the sign. I'm going to give you a shortcut here in a minute. You're not always going to have to do this, but I want to show you why this makes sense. What can I do right here? Could I divide both sides by that stupid negative? So then I get x minus 3. What do I have to do? Less than or equal to, right?
So you just treat that little sign as an equal sign, basically.
Sort of, except for right here. See how it's got a switch?
Yeah, but I'm just saying, like, look at it as an equal sign when you're solving it, and then
When you set up the 2 cases.
Yes.
All right. So let me now. Here's the. All right. So if you want to, so everybody with me. We had the visual. We have, even this is still not the way that I would personally do this problem. This is just explaining why this thing happens. See how the sign had to switch? So if I'm given a problem like this, let's start fresh on this problem. If I'm given a problem like this, I am immediately going to write up my 2 cases. One case is everything stays the same. The other case is the sign switches and the 6 becomes -6, and then I just solve. You can go straight there, remembering why the hell that's true. The same thing happens with the equals part, but when I switch the equal sign, it still looks like a freaking equal sign. Right? So here, when I make that side negative, I've got to switch that sign. So now you just solve x greater than or equal to 9, or x less than or equal to -3. Now the really good question now is, how the hell do I write that in interval notation? You can't write one expression because there's 2 separate sets here, right? So how would you write this in interval notation?
X. 9 is less than or equal to x.
How do you write it in interval notation? What's the smallest?
Bracket.
Good, bracket.
9.
9 up to infinity. The or becomes the symbol U. Has anybody ever seen that? That's the mathematical symbol that really just means or. It means union. It means you can use these or these. So it just kind of adds them together. You can use either one. So this is the way to say or in mathematics. And how do you write this interval notation? What's the biggest it could be? Negative 3. Less than or equal to 7. The biggest it could be is negative 3. And the smallest? Negative infinity. So it's this set or this set.
Wait, why is negative infinity again?
Because I'm going down from negative 3. Positive infinity is way the hell up there. I'm going down. I got to go to negative infinity. Yeah. Cool. Okay, maybe. So let me show you the other way, the less than. Let's kind of work through that, and then we'll do several directly, without all the explanation. We'll just do it. So what was the problem I had up there? It was, I think it was x minus 2 greater than 4. Is that right?
Yeah.
Thank you. Not great, it was less than here, right? Is that the problem I had up there?
Yeah.
Right? Okay. So the greater than is always going to be the restraining order. It's going to say you have to stay at least this far away from me. Right? So you're always going to have two answers, two sets of answers. This one is the one that says stay close. Don't get more than 4 feet away from me. Right? This one didn't even let you get 4, but stay close to me. I don't know where the hell we are. You get the flashlight. Please stay right there. We got horror movies in the branch. So this one, I do the same thing. Now again, there's going to be a little bit of work, and then I'm going to show you the real first step. But I got to show you why it is the way it is. So I do it exactly the same way we just did. One case would be everything stays the same. I mean, because if this is a positive number, the absolute value would just keep it the same. And then the other case is going to be greater than negative 4, just like we just did. The sign switches. But that makes it look like there's two answers, and there really shouldn't be. If you want to stay close to me, it should end up as a sandwich. It should end up as one interval notation. Right? And read this off to me. What does it say reading it this way? Negative 4 is less than x minus 2. And what does this say? X minus 2 is less than 4. So I can go straight to here when I rewrite it. So less than is a sandwich. It says that can't go more down than this, and it can't go more up than this. You guys got it with me? So there's a little bit of memorization here. The less than is the one you can write as a sandwich, because it says stay close. The greater than is the one you have to write in two separate parts, because this is the one that says stay there or there, just get the hell away from it. Right? Hopeful.
So you just solved the left side?
Yeah, now you just solved this directly. We saw a problem with a test that had two sides to it. How do you solve this?
Oh.
Add 2, add 2, add 2. Whatever you do to one side, you do to all sides. Negative 2 less than x less than 6. And isn't that what we got earlier if you look at your notes? Yeah.
How you get minus 4, x minus 2 4?
So it's exactly like we did here. Leave it alone, or change the sign, change the sign. Leave it alone, change the sign, change the sign.
No, the next step.
Oh, from here to here?
Yeah.
Just reading it off. Negative 4 has to be less than x minus 2. Is that cool?
Mm-hmm.
And x minus 2 has to be less than 4.
So why you do this?
To make it easier to work.
Because you write it the way it's like that.
You can work with it this way, but you have to remember then that this is an and. And that's not always easy. If this makes it look like there's two separate answers like there were over there,
No.
I would much rather just learn to go straight from here to there. You can't go more than 4 away from me. So go down to negative 4 or up to 4. You got to stay closer than that to me. Yeah.
So in the test, if we do it either way, do it.
I'm cool with it. As long as you keep it straight, whichever way makes more sense, they're both valid. Personally, I do this. Because then there's a little less work. And it's a little more straight to the point. Yeah.
So since it's and instead of or, when you write interval notation, is it a different sign instead of unity? It's the same thing?
Because the and actually just makes it one statement. If you think about it, and you guys have had this problem before. If you solve this one, you get x less than 6. If you solve this one, you get x greater than negative 2. Well, x less than 6 would be this. Whee! And x greater than negative 2 would be this. Yeah. And says they have to both be true. Where are they both true? Not up there. They're both true in here. And that's why that has the same meaning. And means they have to both be true. Or says you could be there or there. I don't care. Because is it possible for both of these to be true at once? Can you be bigger than 9 or and less than? Hell no. You can't be both. Right? Hopefully.
Okay, so that was just the answer instead of the.
Yeah, this here, and then interval notation would be nice. I mean, the graph we've already got from earlier, and then interval notation just that's the sandwich idea. It's going to have one answer for the less than. Stay close to me, right? Yeah.
So the second way, you don't have to put the word and.
No, definitely not, because there's not 2 of these. The and is what makes it possible for me to do this. So it's already kind of in there when I do that. All right, so let's do this. Let's try a couple problems out straight, without all the explanation. Let's just see how it works algebraically, and then I'll let you guys try a few on your own. So we got this here. Cameraman. All right, let's see. So I give you this problem here. No, Jeff. So how can you immediately rewrite that?
Plus 3 is less than 4 or negative. Or it's greater than negative 4.
So like that. Yes. I want to make that second nature. If it's a less than, you do it. That's got to be in between 4 and negative 4. You got to stay close to me. So it's got to be bookends. You got to be closer to me, right? You can't go past that wall or past that wall. That's why I like the idea of sandwich. Bread, jelly in the middle. Whatever. Right? What visual will make it stick in your head? And now you just solve. Now it shouldn't be that bad. But the less than, just mention less than or less than or equal to. Either one of those you can immediately rewrite as this closed thing. The negative of that, less than this, less than that. Yeah.
If it's greater.
If it's greater than, you got to have the 2 separate ones.
So just.
So we'll do one like that here in a minute. How do I solve this?
You
Add 3.
or the 3.
Add 3.
All right. So real quick, what always tells me how to solve anything is why my x is not by itself. So I don't need. Why would I want to get rid of this poor dude? He's not doing anything to me. I'm in here. There's me. I want to get rid of that 3, of course, first.
2 over 3 divide. Okay?
Yeah, you can divide by 2 first, but then you bring all these fractions in a little too early, right? I'm okay with fractions, especially when I get them at the end of a problem. Yeah.
So let's say if you were to rewrite that one like the way that is, and then you would just make the negative 4 change the sign, right?
Yeah.
I don't.
Technically, this would be this and that,
Oh, okay.
right? So you could do it that way too. I'm open to that, but I'm trying to get you away from that because that opens it up to all kinds of mistakes you can make. If you just realize you can go straight from this to this, you won't make that mistake. Also, this makes sense. Isn't negative 4 less than 4? All right, so I'll make a point when I do a greater than to show you why. If you write it like this for a greater than, it doesn't make a damn bit of sense. So let's see what happens here. negative 7. And now I can
Divide by 2.
divide by 2. And negative 7 halves. Less than 1 half. So then you graph it and you interval notation it. What's simple? Oh, yeah.
Can you explain the way exactly to flip the sign? I'm so confused.
When you're doing absolute value inequalities, you have to flip the sign because it's dealing with the other case deals with the thing possibility of this being negative. And remember, when I divide by negative, don't have to flip the sign. So are you cool with absolute values? You have to have a 4 and a negative 4, right? The two cases. But when you make that negative 4, you got to flip that sign. That's how absolute values react to changing of sign. You with me? Does that make sense? Okay. So here, what symbols would go on both of those?
Parentheses. Parentheses.
Parentheses, yeah, because they don't want to include it, right? And of course, interval notation for these are always nice because it's basically done. Parenthesis, this dude, comma, this dude, parenthesis. So there's a sandwich idea. Stay close. All right, I'll stay close. So let's do restraining order.
And then shift.
All right, so I know from the beginning that this is going to end up with 2 sets because I want to be more than something away. That way or that way. Just stay away from me, right? I can see myself doing this. So I write my 2 cases. Now, if you think you can do this, now watch. This is a mistake. Because people actually, I try to push this on you, and then people start to like this too much, and they want to do it everywhere. But if you try this, wouldn't it be negative 3, greater than equal to 4 minus 5x, greater than equal to 3? Does that make any sense? Is negative 3 bigger than 3?
No.
Makes no sense. I was trying to tell you, you can't set it up like that. So I have to set it up like the 2 cases. Either it leaves it alone, or what's it do? Yeah, less than or equal to negative 3. And then I just solve those 2 things. So you gotta be careful here. All right, you gotta switch that sign around. Over here, the same thing. So you don't make 2 separate graphs. You make 1 graph. It's just going to be 2 different sets on that same graph. Right? So I'm going to have the 1/5 here, 7/5. Notice how I'm not really caring about scale too much. As long as you put things in the right place. So how do I do this guy on here?
Brackets.
Good, bracket. Facing down. I like it outwards. Shade down. And of course, same kind of idea here. Bracket facing up. Cool. Yeah.
The negative 1 divided by 5 is going to be positive because I put x is less than negative 1.
Oh yeah, less than, but the 2 negatives of course cancel.
Oh, that's right.
Yeah.
Why'd you flip the sign in the beginning? I missed that.
That's the second case. The second case always flips the sign, right? Because remember, either this thing is the same or it's the negative of it. And if I divide by negative, the sign has got to switch. So this is sort of a shortcut first step, but I want to make that the way it is so that you don't make some mistakes. But that's why the sign flips. I'm changing the sign, so the sign's got to flip.
How did you know that you were outward brackets again?
how do you know that they're outward?
Oh, because they gotta face in the direction that I'm shading, and I'm gonna shade down, so it's gotta face that way. Here I'm gonna shade up, so it's gotta face that way. Right? So my symbols always face in the direction that I'm shading. So I wouldn't put a parenthesis like this and then shade that way. That wouldn't make any sense. Right? He's like, where's it? So it's always gotta face the way that I'm shading. How would I put this in an interval notation? Yeah, negative infinity up to this dude. Or this dude up to infinity. Yeah. Good. Yeah.
There was one that you had that the internal notation was -2 and 6, and it was the same thing as written out the same thing as the sandwich. How come that one's only 2 and that one like only 1 point and those are 2 points?
Alright, so this one says stay close to me. So I can't go to infinity. Right? If I have to stay within 3 feet of somebody, I can't go to Asia. But this guy says, stay the hell away from me. So here, it wouldn't care. Go to Asia. Go to the moon. That's awesome, right? Go to freaking Jupiter, right? I can hear these things in the noise. Just get away from me. So that's why this makes sense that it's going to go to infinity. In fact, it's going to go to either infinity, right? This would be like go to hell. I've not had a lot of violent arguments, so I'm not sure. I think I just watched it too.
When I look at it too, like, can you say, like, if it's less than, like, your first example, if you're going to have just those 2 points, you do a shortcut, and if you have it another way, you're going to have...
Yeah, so it's less than, you can write it in a very compact form. It allows you to do that, because it is compact. I want to stay close. If it's greater than, I've got to write it separate, because it is separate. Stay away from me or stay close. That actually tells you which way you're allowed to write it, or which way you have to write it, yeah.
From when you got to the second part, where you got between the or, how can you switch the second sign on the second problem?
Okay, so.
Did you just pick one, or did you have
No.
purpose?
Alright. Is everybody cool with this in here? Alright, let me focus on that one more time. This is equal to the same thing. Cool. If that number is positive, if x is -1, isn't this 9? So the absolute value would leave it alone. Are you guys cool with that? But if x is 1, this number is -1. It would actually have to change the sign of this guy. So those are the two things that this absolute value can do to it. To cover my ass, since I don't know what x is, I'm trying to figure out what x could be, I have to do both to see what would happen in either direction. So, if I have this kind of problem here, I have my two cases. It either leaves it alone, or it changes the sign of it. Right? And of course, the first thing I could do if I wanted to is divide that -1 away. So that's the shortcut I take. I say it leaves everything the same, or it changes all of these signs. Because of the fact that I am multiplying both sides, or dividing both sides by a negative. So I do have to flip that sign. Right? But I want to make that second nature, that's exactly bam, bam. Those are the two cases this describes. If I'm here and I say you got to get 3 feet away from me, you can go over there or over there. I don't care. So you go to +3 or more, or -3 or less. That's exactly what that says. Cool. Maybe. Oh. Okay. Here, you guys try this one real quick. Just make sure everybody started this right. What's the very first thing you have to do?
Subtract.
Good. Subtract, you get the absolute value by itself first. Oh yeah, so see right here. Let me see. Oh. Here. You divide it by negative? Yeah. We should keep it. You want those to keep it close, yeah. From the very beginning, I know what kind of problem I'm looking at, right? It's going to be that it's close, the sandwich, right? So how can I rewrite this? Yeah, I want this to go at most that far down and at most that far up, right? So I want to sandwich that dude in between those two extremes. And then I just have to solve that. So don't freak out. I kind of did this on purpose. Don't freak out. This side doesn't just disappear. It just stays 0. 0 is a valid number. It doesn't mean that that part of the universe doesn't exist. It's still there. And then what's the last step here? Yeah, divide by negative 2. So what's got to happen when you do that? Switch the signs. Good. Which if you didn't switch the signs, it wouldn't make sense. 3 is bigger than 0, not less than 0. So the signs have to be switched. Now one little thing, this looks a little weird because we're used to, when you have stuff between, we're used to having smallest to biggest. So you could just switch this around to make it look a little more like what the visual is going to look like. Right? So graphing that and interval notation of that is going to be relatively easy. I've got to stay between 0 and 3. What symbols go on both? The brackets and shade, and so interval notation comes right off of there. From 0 to 3.
I got everything right except that bottom part where you change like 0 is less than.
You don't have to do that. It just makes it easier to read. It's sort of the same thing as stopping here and then accidentally shading up. If you turn it like this, you see that it's less than, you should shade down. What I get sometimes, believe it or not, is I get people put the 3 there and the 0 there. And of course, I mean, you shouldn't do that. 3 is not good. So that's why they leave it like this. So you can leave it like that as long as you realize it says x is between 0 and 3. Just put them in the right place. You don't have to do that step, as long as you keep it straight. Okay, cool. So that's that section. I desperately want to finish chapter 10 and even get into 7 a little bit. So 10.3 should actually be relatively quick, hopefully. If we're all able to graph lines. Yeah?
So the notation is always like the smallest number to the biggest number?
Exactly. Always. Smallest to biggest. So, the next section is about inequalities in 2 variables. So far we've been doing inequalities in 1 variable, and when we do inequalities in 1 variable, I just need a single axis. I just need a real number line. The minute I'm talking about 2 variables, I need xy coordinate plane. And here, if I have something like this, how do I graph that again? Don't overthink it. It's nothing special. No trick question.
7.
There's a 7.
Parentheses.
You have parenthesis, and I shade up. So the whole idea is that is the dividing line between answers and non-answers. And I'm going to overanalyze this so then I can analyze this at the right level. 7 is the dividing line between answers and non-answers. Those are the answers because that says to shade that way, right? Also, it's the answers because 8 is bigger than 7 if I want to test a point. You guys kind of with me? So every single point on this side, of course, works. And every point on that side does not work. So it's the exact same thing in 2 variables, except a point cuts a line in half, what cuts a plane in half?
The shape?
See?
A line?
A line. A line cuts a plane in half, right? So I have a piece of paper, I gotta cut through, I gotta make a line through it to cut the damn thing in half, right? So if I have, for example, y bigger than or equal to negative x plus 2. The first thing you do is the first thing you did here. The very first thing we did here is we plotted 7. All right, that wasn't very exciting here. All right, so it's pretty simple. Here I got to plot the dividing line. Well, here's the dividing line between answers. I'm going to say good and evil. Answers and not answers, right? How do I plot that line? What do I know about that line? What's the y-intercept? 2. And what's the slope tell me to do?
Down 1.
Yeah, down 1 over 1. So there's the line. Okay, make those big, and then all of a sudden it's good. Now, let me show you the technical way to do this. I know one side is going to be shaded and the other side won't be shaded. Because what I really want is where are all the y's bigger than this line. So what you can do is to use a test point, and then I'll show you the way I do it. But I always try to start with the book method. You always use the test point 0, 0 if you can, because it makes it easy to plug in. Unless the line goes through 0, 0, and then you use 0, 1 or something. So you always want to use a point on a side. If a point works, you shade that way. Right? If one point works, they all work on that side. If it doesn't work, you shade the other one. So if you plug in the point 0, 0, does it work? Is 0 bigger than or equal to 0 plus 2? Is 0 bigger than or equal to 2? No. So then you don't shade in the direction of 0, 0. You shade the other way. Yes, ma'am.
Why is it positive 1 instead of negative 1?
Which one's positive 1?
Your x axis.
Oh yeah, so I went down 1 over 1. Yeah, so this is down 1 over 1, or it's up 1, back 1, right? Cool. As long as I end up going down, that's good.
So you plugged in the point into the x and the y, 0, 0.
Yeah, I used the test point 0, 0. It did not work, so that must be the not answers. The answers must be on the other side, and I just shade that way. The way I do it, where are the y's bigger than this? That way. All right, I'm done. So if it's greater, I shade up. If it's less, I shade down. The problem with that is, if I have a really steep line, up and down is a little difficult to determine, right? So it gets a little freaky. So if you don't quite get my shortcut, just plug in a point and see if it works. If it works, you shade that way. If it doesn't, you shade the other way. Is that cool? Yeah.
Greater than or equal to, that's a solid line, right?
I like it, so I'm getting there. So that's why I started
That's
here.
Really freaked me out last time.
I know, because remember in the past we used open circles and solid circles. So here it's allowed to equal the line, so I use a solid line. Solid line. And if it was greater than, I would use a dotted line. That'd be like a whole bunch of little open circles. Right? So let's do another one.
So wait, so if,
Yeah.
if it's true, you shade down, and if it's not, you shade up.
No. If the point you plug in works, you shade in the direction of that point. If it doesn't work, you shade away from that point. Right? If that point works, everything on this side works. If that point doesn't work, nothing on this side works. It must be the other side. So you're guaranteed one side is all answers, the other side's not. I'm just trying to figure out which one. Yeah.
And you can only use 0, 0 as the test point, right?
No, you could use any damn point you want to.
No, I'm saying you can only use it right if it's not.
Oh, I see what you mean.
Yeah.
So as long as the line doesn't go through it. So guess what kind of example I'm getting now? With the line going through it. What do you got, Jeff? Okay. So of course, in order for me to have a line going through the origin, I have to have a y-intercept of 0. So the first step here is to graph the dividing line, which is negative 2x. So what's the slope?
0, 1.
Gotta be careful.
1.
No, I'm sorry, I was pointing to something else. So the slope, slope is negative 2 over 1, and the y-intercept is 0, 0. So start here, down 2 over 1, So there's my line. I'm going to make what kind of line?
Vertical.
Broken line.
Broken line.
A dotted line. That's just like an open circle, right? Closed circle is the same as a solid line. Open circle is like a dotted line. Cool. We're not going to put a whole bunch of little brackets and parentheses, right? We're just going to solid line, dotted line. So now, what test point do you want to use?
1.
Yeah, you can use 1, 1. I always just use 0, 1. What the hell? You can use whatever the hell point. You can use 17, 28. I'm not going to. I'm going to use this. I'm going to use this test point here. I'm going to use 1, 0. So if you plug in 0 less than negative 2 times 1, is 0 less than negative 2? No. So it means I can't shade that way. I have to shade the other. And of course, my way, what y's are less than the y's on this line? Down from there, right? So either way you do it, you get the same answer. Is that cool? Yeah.
So you always shade what's true, right?
Yes. So if you plug in a point, if I would have plugged in the point negative 1, 0, does that work? Y is 0, x is negative 1. Is 0 less than 2?
Yes.
Yes, that works. I would shade that direction.
Okay.
Yeah, you're guaranteed all the points on one side work. So that means all the points on the other side don't work. Okay. Now, of course, they're going to start you off like this. They're going to start you off with 3x minus 5y equals 15. Not equals. Like that, right? And of course, all we have to do then is solve for y. You can even just get x and y intercepts here, right? As long as you can graph that line. I personally always solve for y because I just go ahead and if it's y greater than, up. Y less than, down. So how do you solve this for y? Yeah, you can subtract the 3, sure. Divide by the negative 5. And then so you got to switch the sign. Right. Then you graph the dividing line, and then you test point. Right? So now we got, what do we know about that line? Yeah, the y-intercept is negative 3. What's it tell me to do? Yeah, y-intercept negative 3, and then it tells me to go up 3 over 5. What kind of line is it going to be? Solid. And now if I plug in 0, 0, I always just plug it into the beginning if I'm going to do it that way. Of course, I don't do it that way, but 0 minus 0, is that bigger than 15? No, so I'm not going to shade this way, I'm going to shade that way. Right? Me, I would just go, okay, y less than, down. Yes, ma'am.
What if, you know how we're just doing one equation with, or one. What if you have two? You know,
I like it. Look at you looking at it. So, they will also give you wait a minute. Yeah. They'll give you a system of inequalities, right?
where you have to shade like. When
So all you do then is it's like two problems in one. You do one problem completely. So I'm done with that first line. Now you come to the second line, and on top of this dude, you do him. And in real life, you know, it's funny. In the summer, I don't have the most time to discuss how this applies to real life. But this is probably what's burning in your mind. In real life, we have limitations. We have safe zones. You know, like there can only be so many people going in an elevator. There can only be so much weight on these supporting beams, right? You don't want to drop something on the roof and have the whole building collapse unless that's what you want to have happen. So I have these limitations which very often can be represented by inequalities. This stuff together can't be more than this much weight and so forth. You with me? So if I have a bunch of restrictions, I can see where's my safe zone, right? Where am I allowed to be? So sometimes your limitations could be you can only have this much current running through, but you need more than this much current to run this thing. So you want to see, well, how much current is safe? And in what area can I be? Does that sort of make sense? So if I have two equations here, how do I plot the second one? Y-intercept is 1. The slope tells me to go up 2 over 1. Oh, what kind of line will it be?
Dotted.
Dotted? Okay, this of course I just had to make it like this. You want to find out where these lines cross. That's kind of important. And now which way am I going to shade on this? If I put in 0, 0, is 0 less than 0 plus 1? Is 0 less than 1? Yes, I'm going to shade in the direction of 0, 0. So my safe zone would be where they overlap down there. Don't circle it, but on your paper you just kind of make it a little more pronounced. My safe zone will be where those two, let me draw a little bit better shape. If I did this and shade that way, and then this one and shade that way, my answer would be right there. Do you see that? I just picked really bad slopes for mine, but that's, you just see where the two shadings overlap. That's your safe zone. So if somebody wants to do this, you're like, you go ahead, I'm going to go home. It's going to blow up, dude.
So that was the bottom? So that was the bottom then?
Yeah, so this shading overlaps this shading here, right? And even, here. So that's the answer down there. So if they give you two equations, two inequalities, you just do one, get it all the way done. On top of that, do the other one, and then just kind of make it darker where the shadings overlap, right? That's your answer. That's your safe zone. So a little preview here. I want to warn you about something about rational expressions and equations. The better you are at factoring, the easier this chapter is going to be. So obviously, vice versa is also true. The worse you are at factoring, the harder this section is going to be. Right? So if you're still having trouble with factoring, you have desperately got to see me or a tutor or something to get it firmed up. Here's an example of a problem we'll see. And actually, remind me real quick, before I do this, recall from long, long, long ago. How do I do that? How do I reduce that? Yeah, 10 is 5 times 2. 25 is 5 times 5.
Cancel 5.
Cancel is 5 because division cancels multiplication. 2/5. So how do I factor? What, Jeff? I'll figure it out. How do I reduce this? Yeah, that'll work. I like it. The exact wrong way to do this is go x squares cancel. Right? Because division does not cancel subtraction. You have to factor first, see what things are made of, and then cancel. We never really do it like this. That's silly. I don't see anybody doing it like that, because why would we? I can see that 5 goes into both. Here, I can't see what the hell goes into that. Let me break it up. I have to break it up. So when you break this up, what do you get on top?
X minus 5, X minus 1.
Yeah, you gotta be careful. 6 and 5 are evil. They're gonna multiply by 5, and that's 5 and 1. To add to be -6, they have to both be negative. Right? 5 and 6 are evil. You got the 2 and the 3. That's never gonna work there. Here, x plus 5. So what cancels?
X minus 5.
Yeah, so what's the answer?
X minus 1 over X minus 5.
Right, so real quick. Oh, I got time. I might rush around for it. That's done. You with me? That would be one example of a problem in section, if you're in the white book, section 7.1. If you're in the blue book, I can't remember. Sorry, you'll figure it out. It's the rational expressions and equations section of homework. Section 7.1, you'll see problems exactly like that. Now here's Jeff going one step further. We never have to do this. If x was 4, what number is on top here then?
4 squared minus 16.
Yeah, 16 minus 24 is -8.
Plus 5.
Plus 5 is -3. And what number is on the bottom?
Minus 25.
16 minus 25 is -9. And of course, isn't this...
1 over 3.
Yeah, isn't this 3 over, if x was 4, this would be 3 over 9. This is the same thing. I can kill those negatives. That wasn't a very impressive one. If x was, what do I got? If x was 2, what would this be? 4 minus 12 is negative 8 plus 5 is 3. And this would be 4 minus 25, negative 9. What does that reduce to? Negative 1/3, right? And if x is 2, what's this? 2 minus 1 is 1. What have I done wrong? I'm trying to quickly do this. 4 minus 12 is negative 8 plus 5 is negative 3. Oh, it's negative 3. Over 4 minus, oh, that's right. 4 minus 25 is 21. Thank you.
21.
There you go.
7.
So that's 7. This would be 1 over 7, so it'd be 1/7 the same way. So, I mean, whenever we do something with variable expressions, we are actually doing the exact same thing we would do if they were numbers. So I think I told you that about factoring, right? Whenever you factor something, you're factoring an infinite number of numbers. So here, we're simplifying an infinite number of fractions. Because I can pick x all day long and get different fractions. This is one way to reduce it. Cool. So, of course, we'll also be multiplying and dividing these. This is, in the white book, it's chapter 7. In the blue book, I've given all my blue book homeworks away, but it's a section that's rational expressions and equations. So we'll be adding these, so we have to get like denominators, right? So we'll have variable expressions in the bottom. Yeah.
This one, this is exercise. Which section?
This was section 10.3 in the white book, or 3.4.4.5 in the blue book.
Thank you.
Yep. All right. That's plenty for today. Have a good weekend. I'll see some of you guys tomorrow.
I didn't get this office. I'm not really sure how to do it.
So I like this. The 4 x's come up. So we get 7. So look here. Those 6 y's go up and those 5 y's go down.
Okay.
Right? Both of them move because they're both to a negative power. So then you end up with 6 y's on top, 5 y's down below. Right? So then you can reduce that. Here, those 4 z's go down. So how many z's do you end up with down there? No. 4 z's coming down, you already got 8, 12. Because when they go down, they become positive. Cool.
I don't know what to put with this homework.
Oh, neither do I. It's right there.
Wow.
Yeah.